Hi everyone. So in this lesson, I'm going to teach you the proper way to set up molar mass. And what the heck does that mean, molar mass? So notice that on here, I already have my periodic table all ready to go. So you cannot do this unless you memorized all the atomic masses of every single element on the periodic table. Some of them I do have memorized, and after a while, believe it or not, you will too. That being said, setting up a molar mass is very, very methodical, and it is this way across the world for chemists on how we set this up. So notice I have something C6H12O6, glucose. So we need to find the molar mass. So looking at this, I set it up so that I have C, H, and O. And on the periodic table, you could see that the atomic mass of carbon is 12.01. How many of those carbons do we have in here? Is 6. So we're going to multiply those by 6. It's all additive, if you will. All right. So then we're going to look up hydrogen. Hydrogen is 1.01. How many of them are in here? 12. And then we have oxygen, which is, according to this periodic table, is 16.00 times how many do we have? And that would be 6. Now I'm also going to tell you, depending on the periodic table you have, these numbers may differ slightly. So it's okay. That's up to me to double check your work and to understand, oh, you probably had a different periodic table. So what I'm going to do is that I'm going to multiply across. All right. So with that, putting this into my calculator, I get an answer of 72.06. For hydrogen, I get 12.12. And for oxygen, I have 96. Now, your calculator will say 96, but please remember there's 2 zeros after the decimal point. So now we have everything all set up so that you could just add down. And when you add that together, it's 180.18. Now, there's units. What are the units? Grams per mole. Okay? So this means that if you weigh 180.18 grams of C6H12O6, you have 1 mole of C6H12O6. And if you have 1 mole of C6H12O6, then you have 6.02 times 10 to the 23rd molecules, because remember, this is not an ion or anything like that. It is a molecule of C6H12O6. So I hope you see that relationship between molecules and moles to grams. So now I'm going to erase this particular problem. All right. And we're going to start with another one that's a little bit more complicated, but not in a bad way. So for this next one, let's have Fe2 and SO4, 3. So just like when we were balancing equations, we need to recognize that there are 2 irons, and with the 3 outside the parentheses, we're going to distribute those throughout what is in the parentheses. So we have Fe. When you look it up on the periodic table, it is 55.85. How many of them were there? 2. Then there's sulfur. Sulfur, we established before, is 32.07. And how many did we distribute through that? There's 3, because 1 sulfur times 3 is 3. Oxygen, we established, is 16.00. And because there's 4, but now we're going to distribute the 3 through it, 4 times 3, 12. All right, so this is all set up all nice and neat. When you put it into your handy dandy electric brain, we find out that iron, the total amount of iron is 111.70. For sulfur, it's 96.21. And for oxygen, it's 192.00. When you add that all up, you have 399.91. What's the units? Grams per mole. All right, so that's how much it would be. So again, when you weigh out 399.91 grams of iron 3 sulfate, you're going to have 1 mole of iron 3 sulfate. And when you weigh out that 399.191 grams, you are essentially having 6.02 times 10 to the 23rd molecules. No, it's not even molecules in this point. This is formula units of iron 3 sulfate. All right, so that was a quick lesson on how to do molar masses. If you're not sure what to do, please, by all means, ask me and I will gladly help. And as usual, I also like you guys to draw me little pictures. So how about, because I don't know how to draw a mole and what it should look like, how about if you draw me a cat or a rabbit or something like that? Just a happy little thing, okay? Talk to you guys soon. Take care.